Number 6, question 5. So homework number 6. Okay, so they give me a subtraction. So what we're doing now, what is it we're doing? We are basically looking at models for adding, subtracting here. So right now, so basically we're getting into all the rules. So we looked at adding, subtracting, multiplying, dividing in foreign base systems. That was what we just finished. Now we're saying, okay, how does it work? What are the rules that are in our system? This one right here, well, it's connecting us, adding with subtracting. Have you ever thought about how all of math is adding? Has that ever occurred to you? All of math is really adding. Now, what do I mean? What do you mean? There's subtraction, there's multiplying and dividing. What do you mean it's all adding? Well, what I mean is, how is subtraction, like 7 minus 3, how is that really just adding?
3 plus something 7.
Yeah, that's one good way. Yeah, 3 plus what is 7? Yeah, it's like a adding problem with part of it missing. That's one good way you could say that. Or you could also say it's 7 plus what number? 7 minus 3 is 7 plus negative 3, right? I'm not doing anything fancy there. Just make it negative. Right? So adding a negative. Subtraction is just adding a negative, isn't it? Or it's like you said, what they call that missing addend, this is called. I'm not going to quiz you on the names. But anyway, what's the other part that's missing? So subtraction is really adding, seen a couple different ways. How is multiplying really adding? How is 3 times 7? Yeah, what is it?
You're just adding the same number.
Yeah, you know that's just 7 plus 7 plus 7, huh? So multiplying is really just adding. Finally, how is dividing, like 10 divided by 2, how is dividing really adding?
5 plus 5 is 10.
Yeah, that's one good way, huh? Yeah, dividing by 2 asks what twice will be 10. Yeah, good. Or another way, it says how many times can you subtract 2? You ever thought about it that way? Yeah. Oh, okay, yeah. So please make sure everybody around you can hear me. So 10 divided by 2 is how many times can you subtract 2? So really, all of the operations in math are actually adding. I remember I had heard, I was a young elementary school student, like maybe you'll have someday, and I had heard that long dividing was really subtraction. Like that, it's like, because basically 10 divided by 2 means how many times can you subtract 2? I remember thinking, I'd heard that it was really subtracting, and I couldn't figure it out. And I stayed in on recess, and I spent time trying to figure out how in the world dividing was really repeated subtraction. I had no idea, and I never figured it out at that time. And see, I needed one of you to be an elementary school teacher, to come up beside me in the middle of recess and say, what are you doing, Brett? You're trying to figure out how repeated subtraction is really division during recess. You weirdo, get out of here. Go out and kick the ball or something. No, I'm just kidding. But it would have been helpful if somebody came along and showed me. So anyway, I had a weird and maybe strange interest in figuring that out. So anyway, so there you go. So all the operations are really adding. They all come from adding, don't they? It's all adding. Even calculus. I don't know if you know. Have you seen this symbol before on a calculus book? Maybe not. It means integration. It's something they do in calculus 2 and 3. Anyway, you know what that thing is? What does it look like it is? It's a big S. And you know what it stands for? Sum. What is sum? Adding. Calculus also. All of math. All the way up. It's just fancy adding. It just gets fancier and fancier and fancier. All of math is adding. It's good if you can start to connect that in students' minds. So right here, they're saying write a related. All the operations are related. They're not like totally separate things. How is 14 minus x equals 7? How can we write that as a related addition sentence? What could you write? Let me start with x. X plus 7 equals 14. Yeah? Right? So in other words, the answer to this is the answer to that. X is 7 in both cases, huh? Does that make sense? All right, so 7 plus 4 is 11. Which other three members of this fact family? 7 plus 4 is 11. What's it going to be? Which ones are right there? Is A right? A is a true statement, but it's not related to what we're doing. Yeah, C, huh? C is the same thing said another way. E, yeah, E is the same thing said another way. D is the same thing said another way. Good. I think that's it. Yeah, good. All right. I'll move on. I'll draw four number. Okay, number line also. What are we doing? Like, what are we doing right now? We're trying to give a feel for the operations. You know, there's two things that you do in math as a math teacher to anybody, and you will be a math teacher to people. There's two things you're trying to accomplish. On the one hand, you want to make them able just to crank out answers, right? But then there's also, on the other hand, the concepts, a feel of what's really happening. Does that seem weird? You want to get in tune with their math feelings and an emotional, not emotional level, but a sensible level. So they really sense what adding is, subtracting, multiplying, dividing. And like you guys know, right, 3 times 7, as we said a minute ago, is repeated adding. That they have a sense of what multiplying really is and all the operations. That's what models are for, is to give somebody a feel. So which of these models shows 7 plus 4 is 11?
The first one.
The first. Wait, no.
Yeah, honestly, I
That would
don't
be the
know.
last one.
They all kind of look good to me for a minute here. Draw 4 number line models. Illustrate each of. Oh, those are the answers. Okay, yeah, those, it's not multiple choice. I was getting confused. Those are all, yeah, they all look good. They are all good. They're all good. Those are just 4 different ways you could show on a number line this truth, that 7 plus 4 is 11, right? You could show 7 plus 4, literally, you know, or 11, 7 and what, or 11, 4 and what, or 4 first then 7 instead of 7 first then 4. They're all different ways to show. Now, what's the purpose of that? That's not a good way to compute answers, but that is a good way to give a feel. Why does the feel matter? As you go into higher math, it's more and more about your sense of things, not adding, subtracting. We got calculators for that. If you have little future engineers and scientists, which you will have certainly in your classes, when they go into higher math, it isn't about your ability to add, subtract, multiply, or divide. Calculators, computers take care of all that. It's, do you really deeply understand what happens with the math operations? Are those senses deep within you? And then you can do higher level stuff. So that is an important thing to develop for those who will go far in math and science. Is these kind of things develop a feel for the operation, which is a lot what the new curriculum is into. What's it called? I can't remember the name of it now. Yeah, Common Core. And honestly, I don't even know. I mean, people have asked me because I'm a math teacher. My kids are all homeschooled, honestly. I have no idea exactly what they're doing in the public schools, but some of what I hear I like. I mean, I like the idea that they're getting in there and they're making kids really think about what's happening. Even though I hear a lot of complaints from most of my friends, all tell me they hate it, whose kids are in public school. They all hate it and say it's torturous, and I know how to get the answer, and their teacher makes them do something crazy. So I don't know. I honestly, I'm not a good person to ask. I don't know. But to the degree that it's making people really think about the operations, that is valuable. That's valuable for the long. All right, so let's look here. What multiplication is suggested by each of the models below? So these are models, again, and those are trying to give a feel for some kind of times multiplication problem. So what multiplication problem does that model or show?
4 times 5.
Yeah, 5 times 4, 4 times 5, either way. Yeah, totally. Because it's 4 groups of 5, isn't it? 4 times 5. Or 5 taken 4 times. You know, it doesn't matter whatever order you want. How about this one? What multiplication problem is this?
9 times 5.
Yeah, so however, is it 9 here? 9 times 5? Yeah, exactly. So again, what's the purpose? The feel, right? And that's not a good way to get answers, but that's to feel what's going on that. All right, on number 8, what 3, part A, 3 times z is 6. What does z have to be to make that true? Yeah, it's got to be 2. You can just tell by observation. So we just like the only number that makes that true is 2. How about on B? 24 equals 12 plus 3 times what? Let me get this one out of the way. Now, there's a couple of things. You could solve it formally, using algebra. I know you've all had algebra. But you don't have to. You could just guess at it too. Does that sound weird to say? If it's 24 and this is 12, what does this have to be?
12.
This part has to be 12 also. And how do you make that part 12? What does Z have to be?
4.
Z's got to be 4. So if you can just guess like that, great. You don't have to use formal algebra, but I'll show the formal algebra too in case you want to be reminded of that. So I'll go back. So if you wanted to use formal algebra to solve this, what would you do first? You remember? To solve for Z? Yeah, subtract the 12, yeah. So then you'd get, what would you get? You'd get 12 equals these cancel. 3Z. What's the last step to get Z alone? Yeah, you always divide by 3, and there we get our 4, right? So either way, by formal algebra or by just kind of guessing, both are good. Let's get on to part C here. Part C. Okay, so that one, so Z times 2 plus 4 equals Z. I'm running out of room here. Got this crazy pen that doesn't write very distinctly. Z times 2 plus 4 equals Z times 2. Oh, I can't read any of that. My Apple Pencil broke yesterday. I've got a new one on order. In the meantime, I'm using this little thing. All right, so, whoops, I hit the button. Oh, come on. There we go. Best I can do. Like I'm using a crayon. All right, so there we go. So if you can read that, sorta. So what value of Z makes that true? What's the value of Z that makes that true? Every number. Yeah, every number makes that true. Do you realize that? That's always true, isn't it? Right? Because this is really just 6 times Z, isn't it? 4 plus 2 is 6, you know? Isn't that really just a fancy way to say 6 times Z? And what's the other side? 2Z and 4Z? 6 times Z. Doesn't matter if you put the 6 in the front or the back. It's all the same. Right? They're both 6 times Z, do you realize? Those are going to be equal for any Z you want to put in there. Am I making any sense there? So that would be, the option's off the thing, but you would say any whole number if this was option C. Any whole number will make that true. A look at that. So a system that's closed, what it means to be closed under multiplication means that if you take the items in the set, so when you multiply the numbers in the set, the answers are always still inside the set. That's what it means to be closed. They don't get out of the room, so to speak. They don't get out of the set. The door is closed, they're contained in there. So what am I talking about? So if you multiply 0 times 20, what's the answer? Well, 0. And is that answer still in the set? Well, yeah, 0 is one of the items in the set. So far, so good? It's making sense? But it's not just 0 times 20. You've also got to do 0 times itself, right? Because a number can multiply by itself. What's 0 times 0? Well, just 0. Is that still in the set? Certainly. 20's in there. 0's in there. And now, what about 20 times itself? No, that's 400. That's not in there. So this one is no. It's not closed. Did that make sense what I just did there?
Yeah.
So I found a way to multiply a number times itself and get an answer that jumped out of the set. 400 is not in the set. So the door must be open there, right? Under multiplication, you can get out of the set. It jumped out. Is that good? That making sense? No? So basically the rule is when you multiply numbers, even by themselves, the answer has to still be in there, meaning the answer has to be either 0 or 20. It can't be some number other than 0 or 20, other than numbers in the set. If so, you got out, and it's not closed. It's open. So 20 times, if there's any way to make that happen, then the door's not closed. And there is a way, isn't there? 20 times 20 is 400, and that's not in the set. So this one is not open. Sorry, not closed. Sorry. All right, how about the next one? Let's try another one, see if it makes more sense. 10, 20, 30. How about if, and on it goes, right? Dot, dot, dot. So it's all the numbers ending with a 0, 10, 20, 30, 40, 50, all the multiples of 10, is what they're saying. If you multiply any one of those numbers, let me go to a fresh screen here. Any one of those numbers times another one, like 10 times 30. What do you get if you go 10 times 30? 300, right? It just adds a 0 at the back. So is 300 going to be one of the numbers that's in that set? Well, yeah, it does every multiple of 10. Right? Well, okay, well, how about like 20 times 30? What would that be? Yeah, 600.
It still works. Ending with 0.
Yeah, you're always going to get a number with 0. Right? So, yeah. Yes, this one is closed. There's no way to get out of those numbers, is there? There's no way to get out of those numbers by multiplying. So we would say this collection of numbers is closed under multiplication. There's no way to get out. How about the next group? Is this group closed under multiplication? What is it first? Is it all the even numbers bigger than 10? Is that what they're saying? Yeah, it looks like all the even numbers bigger than 10, huh? So is that going to be closed under multiplication? What do you think? If you take an even number times an even number, do you get an even number or an odd number? You sure? How do you know? Can't you get an odd? No, you're right, huh? It's got to be even, doesn't it? Because you're multiplying, and if you were to line it up, 14 times 12, 2 times 4 is going to be 8. It's got to end even, huh? Even times even is even. So you're going to get an even number. You're going to get an even answer. Hold on. Please let everybody hear me all the way. I'll try to be faithful to get you out on time, but let everybody hear to the very end here. So even answer. So what does that mean then? Is it closed? Yeah, best I can tell, it's got to be, right? Because every answer is going to be even. It's going to be bigger than 10. So that one's going to be closed, isn't it?